This podcast is about redox numbers and redox reactions. So, a couple definitions first. Oxidation is loss of electrons, and reduction is gain of electrons, which seems a little non-intuitive until you realize that electrons are negative, so when you gain them, your number goes down. So that's where reduction comes from. Oxidation and reduction always happen together at the same time, so when they happen in one reaction, we call it a redox reaction because it's reduction and oxidation. So there's an electron acceptor and an electron donor, so then the reaction happens and the electron donor gets oxidized and the electron acceptor gets reduced. So oxidation only occurs together with reduction. They're really important in batteries. Batteries are redox reactions because the electrons are flowing, moving back and forth, and providing the electricity. Another way to think about the definition is in oxidation, the oxidation number increases, and in reduction, the oxidation number decreases. So the first thing we have to learn to do just a mnemonic to help you remember. Leo the lion, that's Leo. Leo the lion says Gur, so Leo, loss of electrons, oxidation, and then Gur, gain of electrons, is reduction. Can be useful. There's a couple other mnemonics on the web if you want to look them up. So there's something that we can write called half reactions, which show where the electrons are going, and that can be handy when the reactions get more complicated, or as a way to think about it. So they always happen together, remember. So here we have a metal, M, reacting with some sort of nonmetal, Y, and they make a compound, My, and I've given them charges, +1 and -1, but it doesn't really matter what the charges are. In this case, the metal M loses an electron to become M+. Because it loses an electron, we write it on the right-hand side of the reaction. And we call this oxidation because it's loss of electrons. So this is what we call the oxidation half reaction. It's called the half reaction because it only shows what happens to M. It doesn't show the entire reaction. And the nonmetal Y becomes Y with a -1, so therefore it gains 1 electron, and because of that we write it on the left-hand side because it's added, and it's reduction because it gains an electron. And we call this reaction the reduction half reaction. And again, they always happen together, but you can write them out this way, and that can be useful for counting up the electrons. So we need to learn how to figure out an oxidation number, and one thing to remember is that charges, the old charges that we learned on metals at the beginning of the year, those are oxidation numbers, but not all oxidation numbers are charges. So an oxidation number is a bookkeeping number that happens for every atom, whether it has a charge or not. And this number represents how many electrons an atom has control over. So here are the rules, and I'm going to go through them and describe the ones that we're going to use the most. So number 1, the oxidation number for hydrogen is +1, and that's because of the group that it's in, except when it's with a really strong metal like sodium, then it's going to be a -1. But we're never going to see this. We're never going to use it. I just want you to know that it's there. Oxygen is -2. Usually, we're not going to see any exceptions, but there are a few exceptions. Elemental atoms are 0, and this does not matter if they are one atom or if they're diatomic. If they're by themselves, they're always 0 because they're not sharing their electrons with anything. Anions and polyatomic anions have the same charges that they always did. So bromine is -1 if it's with a metal and it's an anion. Sulfate anion is still a -2 as a group. Neutral compounds all add up to 0. If it has a charge and it's an ion, it's going to add up to the charge that it has. All the numbers have to add up to the charge. By monoatomic cation, we mean the metal with a charge, like sodium is always going to be a +1, magnesium is always going to be a +2, etc. And we've already seen that transition metals can change their charges, and so can change their oxidation states, depending on what they're with. Okay, so here is some practice to figure out the oxidation numbers, and here we're going to figure out the oxidation number for each element all by itself in a compound. A useful way to do this is to write the number right above. Oxygen is -2, so it gets a 2 right above there. Because there are 3 oxygens, the total is going to be -6. Because they have to add up to 0, all the positives have to add up to +6, and because there are 2 sulfurs, each of them has to be a +3. So sulfur is going to be a +3, and oxygen is going to be a -2. Oxygen's always going to be -2. So in water, because oxygen is -2, each hydrogen has to be a +1 for this to add up to 0. So +1 and -2. Again, P2O5, we're going to be using oxygen. Each oxygen is -2. There are 5 of them, so each phosphorus has to be a +5. And remember that these are not charges. Phosphorus is not a cation, but its oxidation number is +5. In the nitrate here, it has a charge of -3, so we look at oxygen, it's -2. They add up to 3 oxygens, add up to -6. But because it has to add up overall to the -1 of the nitrate ion, then the nitrogen is just a +5. It's not a +6. So nitrogen is +5 here. So on this page, I want you to stop the recording and go through and try to figure them out, and then check your work. So again, this whole number stacking is really useful, especially when you have more than one atom. So oxygen is -2, 3 oxygens add up to -6. The other one that we know from the rules is potassium. Because it's a group 1 metal, it's going to be +1. Because there's only one potassium, it totals up to +1. So therefore, chlorine in the middle here has to be a +5. And there's only one chlorine, so it has the +5 all to itself. So chlorine is +5. And each of these you're just going to figure out what chlorine is. They're labeled, go through, and if you have any questions, come and see me. The next section, same thing, we're going to do chromium. Chromium is a transition metal which changes really often, and use the other atoms to figure out what the chromium is. Okay, so these are the oxidation numbers on chromium, and come and see me if you have any questions. So when we look at a redox reaction, we have to be able to tell what is oxidized and what is reduced. The element that loses electrons has an oxidation number that increases, that's oxidized. The element that gains electrons has an oxidation number that decreases, and that is reduced. Another way to describe the same thing, if an element gets reduced, it is the oxidizing agent because it has to oxidize something else. And if an element gets oxidized, it is the reducing agent because it has to reduce something else. So on the next page, go through and figure out what all the numbers are, and then figure out which elements have numbers that change here. So let's do the first one. Carbon is 0. Hydrogen is +1, sulfur is +6. The numbers are all labeled. Most of them don't change. The oxygens don't change, the hydrogens don't change, so we don't even have to pay any attention to them. Just pick out the ones that are changing, and there's always going to be 2. carbon goes from 0 to +4. So its number goes up, so it gets oxidized because it loses electrons, and that's why its number goes up. So carbon is oxidized, and sulfur goes from +6 to +4. Its number goes down, it gets reduced because it gains electrons, so sulfur is reduced. We are not balancing the electrons, and we're not balancing these equations, so don't worry that the number of electrons don't match. If we were balancing, we'd go through and we would factor all that in, but we're not doing that. We're just going to figure out what is oxidized, what is reduced. So for the next equation, do the same thing. Go through, figure out what all the numbers are, figure out which elements are changing and which ones are going up, which ones are going down, what gets oxidized, what gets reduced. For C and D, do exactly the same thing. Figure out which elements are changing. Notice that there's lots and lots of chlorines in this reaction. If the chlorine doesn't change, we actually ignore it. We only focus on the one change that happens. The rest of them don't matter. So figure out what gets oxidized and reduced, and then figure out what is the oxidizing agent and the reducing agent. Remember that the oxidizing agent gets reduced, and the reducing agent is the element that gets oxidized. Go through and work through it, and then turn it back on and check your work. Okay, so for B, the only elements that change are nitrogen goes from +5 to +2, so it gets reduced. Iodide goes from -1 to 0, so it gets oxidized. And for C, Mn goes from, manganese goes from +7 to +2. Because it is reduced, it is the oxidizing agent. And then chlorine, which goes from -1 to 0, gets oxidized, so it is the reducing agent. Do the same for D. In the next section, go through, figure out, these are only half reactions, they don't show an entire balanced equation, but figure out what element is changing in which direction and what would do that process. So in this case, chlorine is going from +5 to +4, so chlorine is getting reduced. So this would require a reducing agent here. And then go through and do these and then check and see how you did.